So just a quick agenda. These are going to be fairly succinct presentations. So let's just go ahead and jump right into an overview. So the IP Flow Manager was a feature, it was originally a component of the application recognition and control feature that was part of AOS-CX 10.11. So this was used by the AOS-CX operating system to identify specific traffic flows that are initiated by users and devices. They are classified by the application recognition engine and used to apply actions defined by application-based policy, which was introduced in AOS-CX 10.12. In 10.13, we've actually broken that flow tracking component out into a distinct feature. So we called that the IP Flow Manager, and that is actually utilized by application recognition and control, application-based policy. It is also used by the new reflexive policy feature that is also new to AOS-CX 10.13, and that is going to be covered by Shobna in the final session of this series. So for detailed information on the internals of AOS-CX flow tracking, I encourage you to review the application recognition update that was part of the AOS-CX 10.11 transfer of information series. So let's go into a little more detail. So start with platform support for IP Flow Manager. This is supported on the 6300, both standalone and VSF stacks, as well as on the 6400 with V2 line cards only. So this does require a V2, a chassis with V2 line cards using a V2 profile. The different components of the IP Flow Manager. You have the IP Flow Manager daemon, IPFMD, which runs on the management modules or on the conductor of a VSF stack or on a standalone switch. This is responsible for the overall control of flow tracking for the entire system. It maintains the system flow cache, and it communicates with the Flow Manager agent that runs on the line cards or VSF members in a chassis or stack. The management modules also host the Message Queuing Telemetry Transport, or MQTT broker. So this component allows data exchange between the Flow Manager daemon running on the management module or conductor and the agent daemons that run on the line cards or VSF members. On the line cards or members themselves, you have the Deep Packet Inspection or DPI engine. So this is what actually classifies the flows on any ports with flow tracking enabled, and it provides the application ID for that flow, the application name, a category that that app belongs to, URL information to the IP Flow Manager once that classification process has been completed. You have the IP Flow Manager agent that receives the flow packets from the interfaces themselves, extracts that 5-tuple information, as well as the VRF that flow is associated with, and it builds the local line card flow cache. It also publishes the flow data once those flows are classified to the MQTT broker, which is then disseminated to the other line cards as well as the daemon running on the management module. And finally, you have the IP Fix agent, which receives the application parameters from the Flow Manager agent on that line card and forwards that information to an IP Fix daemon running on the management module via MQTT, and that agent or that daemon will export that flow data to collectors either internally on the switch using Traffic Insights or an external collector as configured in the switch config. So from the to configure global parameters for the IP Flow Manager, there is a new flow tracking context at the top level of the config context. So you can see the different commands and parameters that you are available in this context. So you can enable or disable flow tracking globally. It is disabled by default, so it has to specifically be enabled, and I'll go over how to do that here in a bit. Just as you had to do for application recognition in 10.11 or 10.12, you must disable IP source lockdown extended mode before enabling flow tracking. In order to use app recognition, app-based policy, or reflexive policy, obviously, because those all utilize flow tracking to function, you have to enable flow tracking globally before you can configure or enable any of those features. You also have new TCP and UDP inactive flow age-out timers that are configurable from this context as well, and I'll go into details in just a few seconds. So the first new feature that is configurable associated with the IP Flow Manager is a per interface flow limit. So this is the maximum number of concurrent flows per interface configured as a global setting. So the setting you configure here applies to all flow tracking enabled interfaces. That limit is disabled by default. If it is not configured, then you are limited by the maximum scale for the given platform and line card that you are running this feature on. You configure it between 64 and 25,000 concurrent flows on each enabled interface. And to disable the interface flow limit once it has been enabled and configured, you simply use the no interface flow limit command from the flow tracking context. TCP age-out timer. This allows you to specify when an inactive TCP flow is aged out of the switch flow table when there has been no activity on that flow and it has not been removed as the result of a FIN or reset packet received as part of that flow. So the normal method of removing a TCP flow is that FIN reset packet. So if you do not receive one of those packets to terminate the flow before the age out timer expires, then that flow will be marked for removal from the line card's flow cache during the next scheduled processing batch for removing of flows. That timer is configurable to a value between 120 and 86,400 seconds, which is 1 day, and the default age out timer is 10 minutes or 600 seconds. There's also an age-out timer for UDP flows. So this is also configurable from the global flow tracking context. It behaves exactly the same way as the inactive TCP flow timer, except that obviously UDP flows do not get that FIN reset packet. So instead, those flows will age out after a period of time with no activity on that flow. And in this case, the default value for that timer is 30 seconds, and it's configurable between 30 and 86,400 seconds, or again, 1 day. Platform scale for the IP Flow Manager. This is essentially the same as the scale numbers for the application recognition feature. Total flows for the 6300, 6400 V2, with the exception of the two line card part numbers specified, 24,576 flows per standalone switch, line card, or VSF member. For the 6400 V2, those two line cards specified, the max total flows per system, or rather per line card, 61,440 for those two. Flow packets per second, ingress and egress, 3,500 packets per second each across all three system variants. And the number of new connection per second, that's one ingress flow plus one egress flow, 500 new connections per second across all three platforms. So how do you deploy the IP Flow Manager? Pretty straightforward. You start with the global configuration. So the first prerequisite is to disable IP source lockdown extended mode if it happens to be enabled already. Enter the global flow tracking context and use the enable command in that context to enable flow tracking globally. Optional steps after that, you can configure that global per interface flow limit. This will again apply to all flow tracking enabled interfaces. And you can specify non-default TCP or UDP age-out timers for inactive flows. And I just have a couple of examples here. Modifying the TCP age-out timer to be 5 minutes instead of 10, and the UDP age-out timer to be 60 seconds instead of 30. To use the REST API to enable IP Flow Manager globally, you can use the patch method to set system flow tracking enabled to true. You can configure the per interface flow limit via the API using the interface flow limit parameter. You configure TCP, UDP age out timers using their respective parameters. And you can get the current flow manager configuration by using the get method. If you leave all of the attributes and parameters at their default, then the response you get from that API call will include whether it's global enabled. If it is unable to be enabled for some reason, IP source lockdown is not disabled as it's supposed to be, or any other operational issue, you'll have that failure reason listed here. If you have the interface flow limit enabled, you'll have that value here. Operating status enabled, TCP and UDP age out timer values. For troubleshooting the IP Flow Manager, we have the main show command, show flow tracking. That gives you your global and per interface configuration. So you see here, you have the global configuration status is enabled, operation status is enabled, there is no failure reason, everything is working normally. You can see the UDP age out timer, TCP age out timers, these are both set to their default, and I do not have a per interface flow limit enabled here. If you look at each line under the flow tracking port configuration, you can see here you have the interface, whether app recognition is enabled on that interface, reflexive ACL or reflexive policy, and then you have the operation status of flow tracking itself. If you'd like to see the status of a specific interface or a range of interfaces, then you can simply put that interface or range as a parameter for show flow tracking, and it will show only the interface config for the interfaces that you've specified. Some additional resources for the IP Flow Manager feature. As far as user documentation, you have the AOS-CX security guide for the 62, 63, and 6400 switches, Chapter 16, application recognition and control, as well as Chapter 17, which is the IP flow information export or IPFix chapter, as well as the IPFix chapter in the 10.13 monitoring guide. And that is the IP Flow Manager feature.